Hello folks, welcome to the new video. Here in this particular video, what I was doing was, it is a kind of interview preparation video. So here there is a one company, a Periscope. So I took the job description here. If you see, the role overview was lead DevSecOps engineer. So they need to take initiatives for Azure-based infrastructure and the AI platforms, ensuring a secure, scalable, and compliant deployments. This role focuses strongly on Azure AI Studio, HIPAA. I mean, these are compliance, HITRUST, CI/CD automation, and cloud security. So here, this is a work from home opportunity. It is a kind of preparation for you as well as for me also. And I will be going through, each and every category of these questions. Like I have prepared these particular questions as a parts, focusing on Azure architecture and core security services, later CI/CD automation, IAC, then compliance point of view, AI and ML workflows, and observability point of view. So I will be showing the questions and then explaining, basically going through all the questions and answers accordingly. So first of all, why exactly I was took this particular JD and prepared was, if you are also preparing for DevSecOps role that includes some any cloud, especially Azure, and looking for complaints, then this will be a kind of helpful video. Okay, so that is the reason. And as I said, this is the job overview, and here these are the required skills. They are expecting strong expertise in DevSecOps, cloud, and platform engineering, deep expertise in Azure as well as the security services, CI/CD by using a GitHub Actions and Azure DevOps, IAC. These are the basically IAC provision technologies, Terraform, Bicep, and ARM templates. Experience with the HIPPA. I mean, these are complaints basically. HIPPA and HITRUST is basically if the particular company need to follow a health or else supporting for a medical uh, like companies, medicals, patient related information dealing with that softwares. In that particular case, they need to follow compliance with these compliance regulatory bodies. And also, there is a monitoring as well as observability by using a Datadog, and also they are expecting AI and ML workflows deployment. Here, there is a concept of Azure AI Studio, which was preferred, they are saying, and as I said, it was for the Periscope. And moving further, where these are the multiple questions, almost 40 questions are there. Let's quickly go through and have a discussion around it. And also one more thing, I will be providing a complete list of questions along with the answers, whatever I was presenting in this particular video, in the description in GitHub URL. You can go through and you can start. Uh, you can fork the repository if you want. And yeah, moving forward, here is the first category where it covering the Azure architecture as well as core security services. So the first one was, what are the key architectural principles of an Azure landing zone? So here, coming to the answer, here an Azure landing zone is especially a kind of a blueprint for setting up the cloud environment correctly from initial, basically from day one itself. Here, the key principles are identity as the primary security parameter, and network topology. Basically, these are kind of points about that, and resource consistency by using a standard naming and as well as proper tagging, and governance via the Azure policy and role-based access control. So basically, it will ensure before we even deploy a single application, the function is scalable, more secure, and compliant with the standards, and it will sort for the best enterprise standards. And moving further, what is the difference between Azure role-based access control, RBAC, and Azure attribute-based access control, ABAC, RBAC and ABAC? Here, the RBAC, it assigns the permissions, sorry, it basically assigns the permissions based upon the user's role or else the group members, giving the DevOps team a full access to the subscription. And coming to the ABAC, which is attribute based access control, it is more a granular and conditional controls. So here the ABAC allows you to restrict the access based upon the specific attributes of the user, the resource or else the environment. Let's say for example the ABAC, you could say the user can only read the data if their department attribute is finance and the data classification tag is non-sensitive. So it adds a layer of dynamic if then the log if then the logic on top of the static RBAC rules. So finally the RBAC is more into like permissions for roles and groups, and ABAC is more granularity than the RBAC. And moving forward, how is network security implemented in Azure by using a VNets, NSGs, and FireApps? VNets is basically virtual networks, and NSGs is network security groups. Here, the answer was we use a defense in-depth approach where first the virtual networks, VNets, will isolate the resources in a private IP spaces. So within that, the network security groups (NSGs) will act as a virtual firewalls at the subnets or else NIC levels. So here the filtering traffic is based upon the IP as well as the port, which is works on layer 4. Finally, we place the Azure firewall in the VNet hub to filter the traffic at the application level, which is in layer 7. So inspecting the URLs and presenting the threats like SQL injection. So this will basically create a secure perimeter where the only necessary traffic flows between the tiers. And moving further, the fourth question: what role does the Azure policy play in enforcing the governance and the compliance across the subscriptions? So here, Azure policy will act as the compliance policy for the cloud environment, unlike the RBAC, which primarily focuses on who can do something. Like Azure policies will primarily focuses on what they exactly can do. So it allows us to create the rules like all storage accounts must be encrypted. This is a kind of a rule example. And also one more example, no resource can be deployed to the US East region. So when a policy is applied, it can either audit non-compliance resource or else it actively deny their creation, and ensuring our the infrastructure will remains compliant with a standards like HIPAA compliance automatically. And moving to the fifth question, how do Azure Key Vault and managed identities is differ in terms of managing the secrets? Here, for easy understanding, think of Azure Key Vaults as a secure, safe where we can store the secrets, keys, and certificates. So the managed identities is the identity card where it was assigned to an Azure resources like virtual machines or else some app function. So that will basically allow us to access that safe without hard coding credentials. So the magic is here, they how they work together. That is the one. Here, the app uses its managed identity to authenticate the Azure Active Directory, Azure AD, we call. So which then it will grant it access to pull the secrets from the keyword. So this will eliminate the need of storing the connection strings in code or else configuration files entirely. And moving further, what is the best practices to securing an Azure container registry, ACR we can say. So here, obviously securing for ACR will starts with the network isolation, where we should disable the public access and use the private endpoints. So the registry uh, was not exposed to the internet directly. And the second thing was we must enforce the authentication by using a Azure Active Directory integration rather than the admin keys directly. So then the third thing was we need to implement the content trust by using a proper signed images to ensure the only the verified signed images are deployed or moves further. And finally, we integrate the vulnerability scanning tools. So directly that particular vulnerability scanning tools will scan the registries for the image like vulnerabilities or else the malwares before they are pulled or else moved for the deployment. You can consider the tools like Trevi, Snake, or else a twist lock, those kind of tools. And moving to the seventh question, what distinguishes basically differentiates Azure Firewall from Application Gateway (WAF) in terms of functionality? So Azure Firewall, Web Application Firewall. So here, uh, they both serve the different layers of the stack. Here, the Azure Firewall is a centralized one, and a stateful network firewall will focuses on protecting the entire virtual network. So it controls the traffic flow between the subnets, like east-west subnets, and uh, out to the internet, north-south, and application gateway. It it is a web traffic web traffic load balancer that works in the layer 7 when you enable the web application firewall. So it specifically protects web apps from HTTP protocol attacks like cross-site scripting and SQL injections. So in short, we can say firewall will protect the network and app gateway. Coming to the web application firewall, that will protect the web application. So that makes the difference between them. And moving further, what is the purpose of Azure Privileged Identity Management? We say PIM in a security context. So here, the PIM, which is Privileged Identity Management, is all about enforcing the principle of just in time, we can say, to access the least the just-in-time access as well as the least privilege maintenance. So instead of obviously giving a user a permanent global admin rights, which is a huge security risk. So here, what PIM does was it allows them to eligible for, uh, I mean, to the specific eligibility for that particular role. Okay, so like global admin role. When they need to perform a task, then they request the activation. That obviously requires a multi-factor authentication and gets a access for a limited time, like 2 hours or 4 hours, like that. So this dramatically reduces the attack surface by ensuring the high privilege accounts are only active when absolutely it is necessary. And moving further, what are the key capabilities of Microsoft Defender for cloud? Here, the Microsoft Defender for cloud, it provides you two main capabilities. One thing was CSPM, which is Cloud Security Posture Management, and CWP, which is Cloud Workload Protection. So here, the CSPM automatically scans the environment for some misconfigurations like open storage bucket or some missing proper encryption. And it also suggests the fixes for that. So that is exactly the CSP. Now coming to the CWP, which is Cloud Workload Protection, it goes deeper by protecting the actual workloads, like uh, mm, like virtual machines, associated containers, SQL databases. So by real-time detection, detecting the threats like is there any anomalies or malware or any suspicious login patterns. And then it gives us a unified view of security, health across the hybrid as well as multi-cloud environments. So these are the key capabilities of uh, Microsoft Defender for cloud. So moving further, this time the question: how does the Azure Bastion facilitate a secure RDP and SSH access without exposing a public IP? So here, traditionally, to RDP into a virtual machine, you needed a public IP address. So that will exposes the server to brute force the attackers from the internet. Azure Bastion internet. That is the one. And Azure Bastion is a fully managed platform as a service. that provides a secure as well as seamless RDP as well as SSH connectivity directly inside the Azure portal over the SSL port, which is default 443. So it acts as a hardened gateway because it lies within the virtual network. So here the virtual machines do not need the public address at all, need to be exposed. And significantly, by reducing the attack surface while allowing the admins to connect securely from anywhere. So this is how the Azure Bastion will facilitate to secure the RDP as well as SSH access without exposing the public IP address. And moving to the next question, the part two questions, which is the questions with respect to the CI/CD and automation, primarily focusing on GitHub, Azure DevOps. So the question was, what is the standard structure of a GitHub Actions workflow for multi-environment deployment? So for a simple understanding, think of GitHub Actions workflow like a multi-stage assembly line in a factory. So the structure is defined in a YAML file, and usually it starts with a trigger like a code push or something like that. What is the uh, like pipeline triggers, and then it followed by the proper jobs, what exactly the sequence of jobs. So each job will runs on a runner, the server doing the actual work. There will be a multiple runners configured based upon our use case. For multi-environment, there might be a dev and prod. Let's say we typically have the environment with a specific protection rules. So, for example, you can deploy to development environment automatically, but deploying to prod production environment that requires say, some approvals and manual intervention is required. So inside the jobs, we have these steps which are the individual commands like install the dependencies, run this particular test, and then deploy to Azure platform or else perform this particular scan. So this is how exactly the standard structure of the Azure Actions pipeline for multi-environment deployment. And moving further, how does the OpenID Connect, which is the OIDC workflow, function to automate the GitHub actions with Azure? So this is a move away from storing a long-lived passwords. I mean, the main use case was OpenID Connect was this. So let me break it down in the simple words. Here, in the old way, I mean traditional way, we would generate a secret key in Azure and then we copy paste it into the GitHub. And obviously, we hope no one will be stolen this. So with the OIDC, which is the Open ID Connect, there are no keys to copy at all. So instead, we establish a trust relationship between the GitHub as well as Azure. When the workflow runs, the GitHub asks Azure for a temporary access token. Then the Azure will check its particular ID card and it says, I trust this particular specific repository, and the access for a short level token that will obviously expire in automatically in certain time, like half an hour or 1 hour, will be provided. So it's much more secure because there is no permanent password which was setting inside the settings. So for a clear understanding, I framed these kind of answers. I hope so. It is like beginner friendly and easy to like grasp. And moving further, how can the SAST, DAST, and SEA tools be integrated into the CI/CD pipeline? So here is a clear-cut answer. Basically, what exactly these are, SAST, DAST, and SEA? These are the some security checkpointers, and obviously that will perform in different times or is a different sequence, what we can say, different flow. Okay, so here is a simple way where you can remember them in a simple flow. Coming to the first one, which is SAST, which is static application security testing. This is like a spell checker of your code before you run the actual code. So we can integrate it right after the code is downloadable. So it looks for the bugs in the source code level itself. And then coming to the SCA, which is software composition analysis. So this will check the ingredients list, or else we can say libraries. So whatever the libraries you used or imported while building the code, like npm packages. So it scans to see if any of those open source libraries have known vulnerabilities. That is exactly the SAE. And then dash, which is dynamic application security testing. So this will happen after we deploy the application to some like target environment, especially the test environment. So it acts like a hacker, and it will track the running website to find the security holes, like a popular web stop and SQL injection, cross-site scripting, like that. And then we put this near to the end of the pipeline. Why? Because we need a testing environment, I mean, live running environment. That is the reason. And this is how exactly those tools can be integrated into the pipeline. And going further, what is infrastructure drift and how is it detected and remediated in an automated pipeline? So, for simple understanding, I can say, imagine you have a blueprint of your house, basically your Terraform code. That is the blueprint. So, in that blueprint, that says build one kitchen. Okay, but then the developer manually logs into and into the console and adds a kitchen. Now, the actual house doesn't match to the actual blueprint what you have. So here the difference is called the drift. So we detect it by running the plan command in our pipeline before every deployment. The Terraform plan, we can say that particular command. So the tool will compare the real infrastructure against the particular blueprint, which is infrastructure as a code script. So if it sees some extra kitchen, which is obviously a drift, it will flags. And to remediate that particular thing, we usually reapply the code, which removes the manual changes, or else we update the code to officially include the new changes so that it can be managed. So this is how exactly, I mean, what exactly the drift and how it can be remediated in the automated pipelines. And moving further, what is the difference between blueprint as well as canary deployment strategies? So these are the deployment strategies to, I mean, it will be followed to release the code with zero downtime, but they work differently together. And let's see what exactly it makes the difference. First of all, blue green. It is like a flipping a light switch. Okay, so you have two identical environment. One was blue, which is a current environment, and one was green, which is a upcoming or is the new version of deployment. So here you deploy to a green environment, which you test it there, and when you feel you are happy, that means it is working fine. You instantly switch all your traffic of the existing one, which is the current one blue, to the new one, which is green. So it is very fast, but it requires a double environment setup. The server resources will be more consumed. And coming to the another deployment strategy, which is canary, it is like dipping your toe in the water. That means you launch the new version, but only send a 5% of your user traffic to that particular newly launched version. So you watch for the errors, and if everything looks good, you slowly increase the traffic to a certain 50% and then moving 100%. So it is very much safer for complex systems because it catches the issues with a small audience before affecting everyone. So this is exactly the difference between the blue-green as well as canary deployment strategies. And moving further, what are the advantages and disadvantages of self-hosted runners versus the Microsoft hosted runners? So for easy understanding, think of Microsoft hosted runners like a renting cars, renting a car. So it is clean, ready to go. So you don't have to maintain that particular runner, but you cannot customize the engine, and it might be expensive if you drive it all the day. And here the self-hosted runners are like using your own car. So you have to maintain, that means update the OS, patch the security, and you need to maintain on your own. But you can customize it heavily That means you can install specific software and you can keep some private network. So customize accordingly. So we choose self-hosted when we need to save money on high volume builds, or when the runner needs the access to the on-premise servers. So that the public internet cannot be reached. So this is exactly what exactly makes the advantage or disadvantages of self-hosted versus the Microsoft hosted runners. And moving further, how is the hierarchy and the structure defined in YAML pipelines within the Azure DevOps? Here, the structure follows a Russian doll, which is a Russian doll. Uh, Here, Russian doll model, where the stages contains the jobs, and jobs contain the actual steps. Here, a stage will represent a major phase of your life cycle, like the build phase, test phase, deploy phase, deployment to production phase, like that. And then inside a stage, you have a jobs. Here, a job is a unit of work that runs on a specific agent, we can say server. And then inside a job, there we have the actual steps. Here, the steps is a linear script or is a task like running some PowerShell script or else pushing some artifacts to the registry. So this hierarchy will help us to organize a complex pipelines. For example, when we can say run the deployment job only if the test job succeeds. So whenever conditional or else manual approvals, or else whatever enterprise customizations required that can be achieved with this YAML pipelines, especially in Azure DevOps. And this is how exactly the hierarchy and structure defines in the YAML pipelines. And moving further, 18th question, what mechanism are used to prevent the secrets from leaking into the CI/CD logs? Here, this is very much critical for security perspective view. The primary mechanism is called a secret management. So if you define the variables as a secret in the pipeline setting itself, the CI/CD system that might be Jenkins, GitHub Actions, Azure DevOps automatically scans, and also it includes in the logs. So if it sees that extra value which was printed out, it replaces with the like stars instead of direct values. So, however, this isn't a full, foolproof. So here we also enforce the best practices, such as never printing the whole environment variables to the screen, and using the tools like Trufflehog that scans the logs, and if is there any patterns or anomalies that looks like secrets, like a string starting with the SK hyphen for an API key. So to catch everything and identify masking is missed or something like that. So this is the mechanism how to prevent the secrets from leaking uh, from CI/CD logs especially. And moving to the third category of questions, which is the IAC, which is infrastructure as a code. Here we will be covering ARM, Bicep, as well as Terraform. So the first question was, what are the key difference between the ARM, Bicep, and the Terraform templates? ARM templates, Bicep, and Terraform, IAC code. So here, for easy understanding, think of this as your three different languages to talk to Azure cloud. Okay. So here, ARM templates are like writing in a RAM mission code, which is a actual JSON. It is very verbose and hard to read, but it's the native language of Azure for infrastructure. And coming to the another one, which is another language, we can say Bicep. It is like a modern, which is a kind of a wrapper around the ARM. So it simplifies the syntax greatly, and making it much easier for humans to read as well as write, but it is still compiles down to the ARM templates. And moving to the third one, third language, we can say Terraform, which is a universal translator. So it isn't just for Azure cloud only. It works for AWS as well, Google Cloud as well, and other cloud service providers also. So we choose Terraform if we are in a multi-cloud environment, and we choose Bicep. We are strictly with respect to the Azure native cloud because it interacts better with Azure tools. So that is exactly makes the difference between these three languages of IAC. Okay, and moving further, how are the Terraform state files managed, and what are the best practices for remote state backend management? So here, the state file is essentially the Terraform's memory. uh, it remembers exactly what the resources exists in the real life. Here, these are the some best practices. First one was never store this file only. File this in a local system. If the laptop breaks, you lose the map of your entire infrastructure. And the second best practice was use a remote backend mechanism. We usually store the state file in the Azure storage account. And then the third best practice was enable the state logging mechanism. So this will act like a kind of a bathroom door lock. And when one engineer is running a deployment, it locks the state file so the another engineer doesn't actually run a command at the same time, and it will basically uh, won't corrupt the data. That is the how exactly we can maintain the state files and some best practices for remote state management. And move to the another question. What strategies exist for handling the sensitive data within the infrastructure as code scripts? Here, the golden rule is never write the secrets directly into the code base. So if you push a password into the GitHub repository, you have a security incident. Instead, uh, we, I mean, uh, you have a security incident. So instead, we can use the variables uh, instead of directly pushing the password into the GitHub repository. So here we create a variables in the script like a DB password if it is if you are storing the DB password, and uh, we are not giving a actual value of the DB password there. This is a kind of variables, okay, that we are using in the script. When we run the script, we inject the value, whatever the DB password value, from the secure location, especially like Azure keyword for uh, or else from the CI/CD pipeline secret store. So this way, the code will remain clean and the secrets will stay secure in the uh, vault. And moving further, the question was, how are Bicep modules structured to ensure uh, there is a reusability and parameterization? So here, I think of a Bicep module like a Lego block. So you build a small one, standard piece like a virtual network module at a once. So the structure is that structure consists of three parts, which is parameters, resources, and outputs. So the parameters, it is a kind of customizable inputs uh, like VNet name as well as IP address ranges like that. And in the resources, it has a actual Azure code that defines the network. And in the outputs, like what exactly the modules gives back, the ID of the network which is created. Now, every time we need a network for a new project, so we don't rewrite the code, we just call that particular Lego block and give it a different parameter. So this is how exactly we can uh, reuse as well as parameterize the basic modules. And moving further, what tools are used for scanning the IAC for security misconfigurations? The tools like CheckOV, TFSec, like that. So these tools basically act like a spell checker, as we said in the slash dash CAKs. It is. spell checker for the ISA code. So before we apply our infrastructure code, we run these particular tools like checkov, tfsave, trv. So they read the Terraform or else Bicep files and look for the common mistakes, like checking if the storage account allows you public access, or else if the database firewall is open to the whole world. If they find these mistakes, they fail the build and they report immediately and forcing us to fix the code before we even create the infrastructure. And moving further question, what is the concept of idempotency in the context of IAC, which is infrastructure as a code? Here, this is a fancy word for a single concept, which is do no harm if it's already done. So if you run the script that says create a server and you run it once, you get one server. If you run it again by accidentally, an idempotent tool will check that and see what this, I mean, is that particular server is already exist, and if it is already exist, do nothing. So it won't try to create a second server or else crash the existing one. It ensures that the end state of your infrastructure is always matches to your code. So no matter how many times you run it. So that is exactly the concept of idempotency. Do no harm if it's already done. And moving further, how are dependencies and lifecycle rules managed when using the Terraform? Here, the Terraform is smart enough to figure out the most dependencies automatically itself. So, but sometimes it needs some help. So we use depends on to explicitly tell the Terraform, wait for this particular task to finish before starting the other task. For especially the life cycle rules, we use them to protect the resources. Let's say, for example, prevent destroy. That means it acts like a safety lock or check. If you try to delete a critical database by changing the code, Terraform will refuse to do that and forcing you to manually remove the lock first. So this will basically prevent the accidental outages. And this is how the dependencies and lifecycle rules will be managed by using the Terraform. And coming to the another category of questions, which is the compliance perspective, HIPPA, HITRUST compliance. So as I said, HIPPA and HITRUST, it works when we are working with the patient crucial information. Coming to the first question, what is the difference between HIPPA regulations and the HITRUST CSF regulation certification? So for better understanding, think of HIPAA is the law and the HITRUST is the standard checklist to provide, sorry, to prove you are following that particular HIPAA law. Here, the HIPAA is a US federal regulation that says you must protect the patient data, but it's often vague. And coming to the HITRUST, where the full form was Health Information Trust Alliance. So it takes that particular law and combines it with other standards like ISO standard, NIST standard to create a very specific perspective set of a security control. In the industry, saying we have HIPAA compliance, we organization following HIPAA compliance like that. So that is their own plan, saying we are HITRUST certified like that. We if we are HITRUST certified, that means an independent auditor verified it. So this is exactly makes the difference between HIPAA and HITRUST. And moving further question, how are Azure native services mapped to HITRUST common security controls, CSC we can say. Here the simple answer was we don't have to invest a security from scratch. The Microsoft provides a mapping called Azure HITRUST implementation guide. So it acts like a translator translation directory. Let's say, for example, if the HITRUST control says you must control who access the system, we map that to the Azure Active Directory. That means Entra ID. So if it says you must encrypt the data, so the Azure will map it to the Azure disk encryption. So we use this particular guide to select the right Azure service that automatically satisfy the specific requests of the HITRUST framework. And moving to the further question, what are the specific encryption standards which was required for PHI regarding the data at rest versus the data in transit? Basically, the PHI, which is protected health information, which it requires the encryption everywhere, but the IPs differs. There are two data encryption types, which is a data at rest, data at transit. Here, data at rest, that means files sitting on a disk, that means at rest position. So we must use AES 256 encryption mechanism in Azure. This is enabled by default. So the storage account as well as SQL databases. So we often use a customer managed keys in Azure keyword. So we have a fully control over the encryption key. And coming to the second one, which is data in transit. Here, that means data moving across the network. So here we must use ALS 1.2 or its higher version. So this essentially creates a secure tunnel like an armored, and so no one can shift the data while it moves between the user and the server. So we strictly disable the older insecure protocols like SSL v3 like that. And moving further, what are the audit logging requirement for compliance utilizing the Azure activity logs and diagnostic settings? Here the simple answer is compliance requires a paper trail of everything. In Azure, here we can split this into a two logs. One is activity logs and one is diagnostic settings. Here we can say activity logs as a control plane where this records who changed what. Let's say example, John deleted your virtual network. So this is usually on by default, it will happen activity log. And coming to the diagnostic setting, which is we can say data plane. So this records who accessed what data. So let's say example, a nurse read the patient ID data, this one. So this is of by default and must be tuned on and sent to a destination link destination like log analytics workspace or is some storage. For HIPAA compliance, we often need to keep these logs immutable, that means undeletable for up to 6 years. So this is uh, like audit logging requirements for compliance. And moving further, what are the considerations for data residency and sovereignty in healthcare cloud architecture? Here, the data residency is about the physical location of the data. Some countries or as uh, states have the laws that says patient data from this region cannot physically leave this particular region or country like that. So in Azure, we can handle this by strictly pinning our respective services to specific regions like US East or West Europe, like with respect to specific region. So we must ensure that our backup and replication strategies doesn't automatically copy that data to a data center in a different country. So which would be a like a law violation there, or else as per the requirement. Here in that case, we can use the resource logs to ensure no one accidentally moves a resource to a forbidden region. That means a non-allowable region. And moving further question, what is the scope of your business associate agreement? That means BA, business associate agreement, when using a cloud providers and software as a service vendors. So here the answer was the BAA is a legal contract that defines who is responsible for what. When we use Azure or else a syndicate, we are the covered entry, covered entity or else a business associate and the Microsoft or else the syndicate or the business associates. The BAA essentially says, hey Microsoft, these you provide the secured infrastructure, that means the building and the logs, but we, that means the customers, are responsible for how we configure that particular logs and how, I mean, who exactly we give the keys to manage that. So we cannot legally use any cloud vendor to process a PHI without a signed BAA. So this is a like what exactly scope of BAA when using a cloud providers or the SaaS vendors. And moving further question, what access control model are best suited for handling uh, protected health information, PHI, what we discussed here in Azure? So for PHI, we need the strict model, which is least privileges. That includes zero trust, which is we trust no one, even inside the network also. And second one was role-based access control. That means we don't give access uh, to the generic. I mean, we don't give users a generic admin rights. We create a specific roles like EM or data reader like that. So which only allows a reading records but not a deleting them. That is exactly the RBAC, multi-factor authentication. So that will helps to uh, mandatory maintain, I mean mandatory for everyone. A password alone is not enough to access the patient data. And just in time access, that means JID access, we can say, for high privileged admins, they should access, I mean, they should only have the access when they are actively working on an issue, not entire 24 by 7 like that. And moving to the another category of questions, which is AI and ML workloads, especially the Azure AI Studio. The first question was, what are the core components and architectural elements of Azure AI Studio? Here, for better understanding, think of Azure AI Studio as a one-stop shop, or else an IDE, that means integrated development environment, specifically for AI. So instead of jumping between a different tools, everything is in one place. The core components includes projects, data, computers, models, endpoints. So basically, the projects, it is basically a folder to organize your work, and data, it is a place to register and maintain and manage your versions of your training data. And computers, which is basically a virtual machines, that might be a GPU clusters that do the heavy lifting of training the model, and the models, which is a registry where you store different versions of your AI files, and finally the endpoints where these are the doors that other applications knock on to get an answer from your AI like workloads. So it basically brings the whole life cycle together. So this is exactly the core components of architectural elements of AI Studio of Azure. And moving further, what are the stages of an MLOps lifecycle for model training, model registration, and deployment? So here the MLOps is just a DevOps applied to AI model. So here it follows this flow, which is data presentation, training layer, evaluation, registration, deployment, and monitoring. So in data presentation, there will be a cleanup and organizing data activity. And in the training phase, where that will be feeding the data to the algorithm to teach the model. Evolution, which basically involves testing the model to see if it's accurate enough. And then a registration, where it was saving the model file, like a .pkl file, into a secure registry with a version control, like V1, V2, like that. And then deployment, that means taking that model and wrapping it in a web service like a Docker container. So It can respond to user requests, and then monitoring finally, where it will be watching the model to ensure it doesn't get dumped over the time. And then moving to the next question, what mechanisms are used to secure the endpoints which was created within Azure AI Studio? Here, since the AI endpoints are essentially web APIs, basically the URLs, uh, we ensure them to, I mean, we secure them the same way we secure the web applications. That includes authentication, network isolation, traffic control. Here, for in the authentication, we use the Azure key-based authentication, where you need a secret key to talk to the endpoint, or else Azure EID, that is basically Entra ID, where a user needs to log in, and network isolation, where we can deploy the endpoint inside a virtual network. We can say VNet, making it inaccessible from the public internet. Only our I mean, internal application can reach it. And the third one was control and traffic control. Um, I mean, secure mechanism first. So we use Azure API management in front of rate limit users. Sorry, in front to rate limit the users, ensuring no one spams and our AI with the requests. So that is exactly how the traffic control, network isolation, and authentication will secure the endpoints which was created within the Azure AI Studio. And moving further, what techniques are used to de-identify the data in AI training data sets to ensure the privacy? So this is a crucial for healthcare industry. So we cannot obviously feed the raw patient names or else the IDs into the AI. There will be anonymization, masking, differential privacy, as well as pseudonymization. Pseudonymization. So basically, let's go one by one, which is anonymization, which is a simply removing the names and the IDs for making it anonymous. Masking, that means replacing a sensitive data with symbols. Example, uh, let's say there is a patient name, John Doe. That means J star 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 and D star star star, like that. And pseudonymization, where that means replacing the ID with a fake identifier. That means patient ID with the 1, 2, 3, 4, 5, 9, 10, 12. So the data cannot be traced back to that particular person without a proper separate key matching. And the another technique was differential privacy. That means adding a little bit of statistical, that means noise to the data. So this will ensure the AI learns the pattern. That means example, smokers get cancer more often. So without memorizing a specific individuals, this will automatically train the data. And moving further question, how is model drift? That means basically a concept drift and data drift monitored in the production AI systems. So for the answer, for clear understanding, think of AI models like a self-driving cars, which was trained in the summer season. So if you drive it in the winter without retraining the model, it might crash. Why? Because the roads looks different. This is exactly the difference, model difference. So here there is a concept of data drift as well as concept drift. Data drift is basically the input data was changed. Example, let's say the patients are suddenly sicker on average than before. So this is the data. And coming to the concept drift, the relationship got changed. Let's say example, a definition of a risky loan changed based on the economy. So it is entire concept was changed, right? Instead of patient data or something. So we monitored this by tracking the accuracy and the prediction distribution over the time. So if the graph suddenly drops or looks weird, we trigger an alert to retrain the model with the new database, new data set. And moving to the another question, what are the key principles of responsible AI? Like fairness, reliability, privacy, especially in Azure. So here, the responsible AI is about ensuring the AI does a good without doing any harm. So here, let's talk about fairness, reliability, privacy and security, transparency. Here, the fairness, that means making sure the AI doesn't discriminate. Let's say, for example, ensuring a medical AI doesn't I mean diagnose one gender more than the another gender. And then the reliability, that means the AI should work consistently, so it shouldn't crash or else give a wrong answer just because it's confused. And the third one was privacy and security, that means protecting the data, and AI learns and processes, uh, basically protecting that particular data, whatever processes the data as well as learning data is. And transparency, that means being able to explain why the AI made that particular decision. So here the Azure provides the tools like explainable AI that highlight which factor, let's say example, blood pressure versus age. So that influenced what exactly influenced the decision. So that brings the transparency. So these are some key principles responsible AI in Azure. And moving to the another last category of questions, observability and tooling. So here we'll be seeking a Datadog as well as SendGrid. So the first question was, what is the architecture for integrating the Datadog with an Azure Kubernetes service AKS clusters? So here, to make Datadog see inside what exactly inside Kubernetes clusters, we need to install a small software agent, which is called a Datadog agent. So we deploy this particular agent as a daemon set in a Kubernetes. Then this is a just a kind of a fancy way of saying put one copy of this agent on every single computer node in the clusters. So that particular agent will sit on the node, and then that will listen to everything what is happening, like metrics, CPU usage, what is the network traffic, and it will obviously collect the logs from the containers, and it will send all the telemetry, all that particular telemetry back to the Datadog cloud dashboards. So it acts like a security cameras inside the cluster. So moving further, what is the technical distinction between the metrics, logs, and traces in observability point of view? So these are the some three key pillars of monitoring best. I mean, for clear understanding, here is the best explanation with a core example analogy. So metrics, logs, and traces. Coming to the metrics, these are the numbers on your dashboards, car dashboards, like speed, what is the fuel level, what is the rotations per minute. So they are great for spotting the trends. Let's say example in our technical analogy, the CPU is getting hotter over time. So they are just numbers, metrics. And coming to the second one, which is logs. So these are the next records, sorry, text records. So the text records, the black box, that means a kind of recorder. If the car breaks down, you read the log to see the error messages. Is it a engine failure? So this is exactly in the text. Metrics are the numbers, logs are the text, and third one, which is traces. So this is the GPS route of a single trip. So it shows exactly where the user went. That means front end, you went to API, user API, that calls the database, like that. So they help you to find the bottlenecks. Let's say, for example, in the technical example, we spent 90% of the time writing at the database traffic light. So these are the traces basically. Okay, so metrics, logs, and traces. So this is exactly the difference. And moving further question, what strategies are used to configure alerts for security anomalies and perform on the performance thresholds in Datadog? So here we don't want to get an email for each and every little blip. We configure a smart alerts that includes threshold limits, anomaly detection, security alerts. Coming to the threshold limits, only the alert is triggered if the CPU goes above 90 percentage and the two continuously for 0.5 minutes. Then the alert should trigger. And anomaly discussion. So this uses AI instead of mixed number or Datadog will learn what is normal for the user app. If the traffic is usually spikes at 9 a.m. but suddenly spike at 3 a.m., so it flags it as a anomaly. And coming to the security alert, where we monitor a specific logs for keywords like unauthorized or else permission denied. So, and then it will trigger a critical alert that might be a Slack message or else a PagerDuty message immediately, and it will help to further unless vulnerabilities. Moving to the last further question, last but one question. How does the Datadog APM, which is Application Performance Monitoring, facilitate a distributed tracing? Here, the simple answer was the modern apps are like spider web. So one request hits many different microservices. That means here the distributed tracing assigns a unique ID to a request at the very start stage. As that request passes from the web server to the auth server to the database, it passes that particular ID along with the Datadog switches. I mean, Datadog stitches all these steps together into a virtual timeline, sorry, visual, proper visual timeline, which is called as a trace. So this basically allows us to pinpoint exactly where the request slowed down. Uh, let's say we can say the whole request took 2 seconds, but 1.9 seconds were spent waiting for the database. So this is where we can fix the code and help to debug more. So this is how exactly the Datadog application performance monitoring facilitate a distributed tracing mechanism. And then moving to the final question, what is the process for securely configuring SendGrid API keys using a Azure keyword references? Here, we never paste the SendGrid key in our code. It is the secure flow we need to follow, which includes store, reference, and resolution. In the store, basically we generate the API key in SendGrid and copy it to a Azure keyword as a secret. And then reference. Here in our applications, the configurations like an Azure function or as app service, we don't put the key value. Instead, we use a special syntax which is called as a keyword reference. It looks like at the rate Microsoft keyword, Azure keyword like that. And finally, the resolution when our app starts up, the Azure sees that particular reference and automatically reaches into the keyword, and then it will grab that particular secret, and then it loads into the app's memory. This way, the developers writing the code will never see the actual, I mean, the code itself never see the key. And if you need to if you need to rotate the key oftenly, we just update it in the vault without touching the code. So these are the questions which covering a holistic concepts as per the job description that primarily focusing on observability tooling, AML workflows, compliance perspective, IAC, CI/CD, and Azure Architecture as well as core security services. So as I said, I will be providing this in the description. Kindly check it out, and thank you so much if you are still here watching till the end. And all the best for your preparation and learning.